Namaskar, welcome to the CTET preparation classes of mathematics. So I am Manohar H, Registrar of Education Mysore, Senior Research Fellow, Department of Education, RI, Mysore. So in this session, we are going to discuss about the concept of cube and the concept of the cube root. Okay, so majorly in this session, we are going to cover the concept of cube and the cube root and how we can identify the cube and cube root through the prime factorization method, and also some of the tricks we will also see when we are trying to see the cube and cube root problems. We will also see some of the tricks how we can solve easily without by through the elimination method. So these things will apply when we are trying to solve previous year question papers. Okay, so coming to the next. So if you analyze previous question papers of this concept in the CTET previous paper 1, paper 2, the questions which they asked, okay. So probably, so mainly they are asking, every year in the CTET paper 1, paper 2, 1 to 2 questions asking from these concepts, cube and cube, concept of the cube and cube root, okay. So what are the concepts which are involved in this, concept of cube and cube root in the unit? The cube of numbers, cube root by prime, factorization, and the cube root of large numbers. When they give the large numbers, how we have to identify the cube root, and how we have to identify the cube root through the prime factorization method, and the cube root of fractions when they give the questions in the form in the form of fractions, and they ask us to find the what is the cube root of the given fraction. In such a cases, how we can do, and then cube root of decimals. So when they give the question in the form of decimals, they'll ask us to identify the cube root. So when they give the decimals, how we have to solve, okay. And then we also see some of the unit digit tricks. So whenever we try to solve the problems, try to identify the cube and cube root, okay. So we will see the digit first unit digit, and we'll try to see the easiest way to solve the problems, okay. So there are some of the properties which we are also going to look at. A to the power of cube is equal to 3, so that is a to the power of 9, and ab whole cubed is equal to a cubed and b cubed, okay. So based on these concepts, every year in the CTET examination, in the paper 1, paper 2, minimum 1 to 2 questions they have been asking, okay. So whenever we are trying to solve this cube and cube root of the concepts, okay, try to remember some of the tricks, okay. So where group prime factors in triplets, okay, whenever they try to do the prime factorization, make it into triples, okay, such as, like, for example, if you say 216, so the factors of the 216 we can write as 2 into 2 into 3, 3 into 3, 3, okay. So where we have tried to, since we are talking about the concept of the cube, we try to represent the factors in the form of the triplets. So and then use the last digit to identify the cube root. So whenever they give whenever they give the question, ask you to identify the cube root, okay, check with the last digit, okay, whether it is last digit is forming the cube root, which is ending with the cube root, okay. So and then count the digits to estimate the cube root. So there are some of the questions where they ask, okay, they give the cube and digits and they ask you to identify the estimate the cube root. In such a cases, how we can solve? We can use the formula of cube root n, okay. So and then we also see elimination method, okay. So these are the basic concepts which are covered in the cube and cube roots, and we are going to see how one by one through the previous year questions, and we also discuss the which is the concept which is involved when we are trying to solve. So now coming to the next slide. So you can see here the question is the cube root of 19,683 is, the options they are given like this: option A 19, option B 23, option C 27, option D is 29, okay. So what we need to identify here, they have given the number and they are asking us to identify the cube root of the given number, okay. So how we can see that? So before, instead of solving through the regular method, let us see from the options only, okay. So now the question is 19,683. The options are 19, 23, 27, 29. So now, if you see the unit digits, okay, 83. Now see the unit digits of the given options, okay. When you see the 9, okay, So what is the, there's 9 is ending with again 3, no, so what is the 9 cubed? Okay, so if you see the 9 into 9, 81, 81 into 9 again if you see, okay, so 81, so it is not going to end with the 3. Similarly 23, if you see the 3 cubed is 27, it is ending with the 7. Okay, if you see the 7 is ending with the 3. Okay, so that means there is a chance of, this might be the probably the answer. Okay, so if you see the 9 again, it is not unit digit is not going to end with the 3. Okay, so by seeing the options itself we can identify that, okay, 7 where 7 is the going to end with the 3. Okay, so like that, okay, we can try to eliminate the other options and we can try to identify by seeing the only applying the unit digit of the trick. Okay, so now, so identify the perfect cube using the last digit and estimation. Now check the last digit here. The last digit of 19,683 is the 3 and the cube numbers ending with the 3 are 3 cubed is 27. Okay, 13 cubed is 2197, 23 cubed is 12167 and only 27 cubed is 19683. So this is the only one cube which is ending with the 3. Okay, so 33 cube if you see also, this is also going to end with the 7, so it is not a cube root of the 19,683. So now we can see only 27 cubed. Okay, 27 into 27 27 if we do, then we will get the 19,683, so which is the matching of the question. Okay, so therefore we can say that 27 is the cube root of the given number 19,683. So answer C is the correct one. So now the concept which is involved in this, okay, so whenever they ask you to find the cube root, the 3 to the power of cube root of n is equal to x, so that means we need to identify x to the power of cube is equal to n. Okay, so now second question, the question is like this. Okay, the find cube root of 0.00729 by and 0.085184. okay, so what is the form of this given question here? So this is given in the form of the fraction. So what we have to do, so we need to the formula of the fraction we need to apply here. Okay, so now let us take the in which formula it is there. Okay, the cube root of a by b, where a is equal to 0.00729 and b is equal to 0.085184. okay, so this can be has written as cube root of root a by cube root of b. Okay, so you can write, you can be written like this. Okay, now the value of a is what? Value of the a is 0.00729. the value of b is 0.085184. okay, now this is in the form of decimals. What we can make it into exact numbers. Okay, so how we can make it into exact numbers? We can take it last 729 and 85184. so for these numbers we try to identify the cube root. Okay, so this we can write it as cube we can write it as cube root of 729 divided by cube root of 85,184, which is in the form of same again in this form we're trying to convert here. Okay, now so if we like, okay, so now the value of 729. so now let us recall the roots of the cubes. Okay, so the 729, so it can be 9 to the power of 3. Okay, similarly 85,184 or 184, it can be the value of the 44 cube. Okay, so therefore we can write this one as 9 by 44. Okay, so can we check the answer, which is 924? Option A is a 9 by 44. Okay, even you don't need to do this much. Also by seeing the options itself we can identify that. Now the value, so if you see the option C 9 by 44, option B 7 by 44 and option C 3 by 44 and option C 6 by 44. Okay, so if you see the all the denominators, 44 is the common here. So that means the value of 0.085184 is the cube root of the 0.085184, the value is the 44. so now only we need to try to identify the 720 numerator value. So the numerator value of 0.00729. so now if you look at the 729, okay, so look at the 729, so where 9 is ending with the which number has the 9 is ending with the cube root. Okay, so if we call the cube roots, then we can identify that 9 cube it is the ending with the 9, so that is the perfect square perfect cube of the 9. So therefore 9 cube is equal to, we can write 9 into 9 into 9. If you do that, 729. Okay. So with this, we can identify the given option, which is the correct option. So you have to remember, take cube root separately for the numerator and denominator whenever they ask the fractions. Whenever the question has given like this in the form of the fractions, always you try to separately write for the numerator and denominator. Always you try to simplify the numerator and denominator, then try to divide, we'll get the solution. Okay. Now the next question, the cube root of minus 5832. Okay, so we need to identify the cube root of the given number. Okay, now what are the options that are given here? Option A minus 14, option B minus 18, option C 16, option D 18. Okay, so now if you see that, okay, so this problem we can solve in the two ways. Let us try to see how we can solve this one. Okay, through the regular method, applying the concept. Now if you look at the question here, they ask us to identify the cube root of minus 5832. Okay, so if you look at the question here, the cube root of a negative number is always the negative only. So now if you see like minus into minus plus, okay, again if you multiply the minus, again it becomes a minus. So always negative number is, cube root of negative number, always it becomes the negative. So therefore we can keep the negative outside here. Okay, so now this is the given formula in the form of this one. Okay, so now if you write cube root of minus 5832 as minus, if you take out, okay, cube root of 5832. Okay, now for the 58, since they are asking us to identify the cube root, okay, for the given number 5832, let us try to find out the prime factorization. Okay, so now if you find the prime factorization, okay, for 5832, we will get the 2 to the power of 3 into 3 to the power of 6. You know how to find the prime factorization. Okay, like 5832. Okay, then do the with a with a 2. Okay, 2 2s are 4. Okay, 2 9s are, then again 2 1s are, 2 6 are. Like, so if you do it, keep on like keep on, if you do factorization, we will get the 2 to the power of 3 into 3 to the power of 6. That means 2 times the 3 times of the with the 2 we are trying to divide, and the 6 times with the 3 we are trying to divide. Okay, so now after getting the factors of this, okay, group the factors in the sets of 3. Okay, so that means we have to, since we are talking about the concept of the group, so in the concept of the cube, okay, group the factors in sets of the 3. Okay, so now how we can write this 5832 is 2 to the power of 3 can be written in the group as 2 into 2 into 2, and 3 to the power of 6 can be written as 3 power of it can be written as 3 to the power of 3 into 3 to the power of 3. Okay, so this in the group we can write it as 3 to the power of 3 into again 3 to the power of 3. This is the 2 to the power of 3. Okay, now take from the group, take one number from the each group. Okay, so how many groups we got it here? There are 3 groups which we got. One is the 2 to the power of 3, and another is the 3 to the power of 3, and another is the 3 to the power of 3. So there are 3 groups we got it. From each group we have to take it the one number only. So that means for cube root of 5832 we are taking, so from the group each number, okay, 2 into, from this group we are taking the 2, from this group we are taking the 3, and from this group we are taking the 3. Now we try to multiply the numbers which we have taken from the groups. Okay, now if you multiply this, 2 3s are 6, 6 3 is 18. Okay, so now this is the obtained answer. Okay, so therefore cube root of 3 minus cube root of 5830 value is the 18, we got it. But the question is what is asking, it is the cube root of minus they are asking, so therefore the answer is the minus 18. Okay, so which is the correct answer? Option B is the correct answer, minus 18. So in order to find the perfect cube, since 18 cubed is equal to 5832, so the cube root of 5832 it becomes a 18. Hence we say that it is the cube root of the value of 5832 is a minus 18. So even you don't need to do like this, complete, all by applying these formulas all the measure. By seeing the even options also we can try to identify the cube root of for this question. Okay, so how we can see that? Okay, now so similarly the same question only. So now how we can see that? Okay, if you observe the unit digits of 32. Okay, so what is the number which is the number of like 4, does it ending with the 2, the 8? Obviously it is no. Okay, so 4 4s are 16. Okay, again if 16 into 4, okay, like this. Now 18 you see, again 16 you see, 18 you see. Okay, so only the 18 is the possibility of the 16 is not the cube of, 6 cube is not ending with the unit digits of the 2. Okay, so only 8 is the possible. Okay, so in this way also we can, by just eliminating the options also, we can try to identify the cube root of any given number. So if you see the 18, 8 into 18, 64, again 64 into 8 if you do, again 64 into 8 if you, it will 32 something. So that means the unit digit again it is ending with the 32. So therefore by eliminating also we can try to identify the answer. So since the question has a minus, the cube root of negative numbers always will be the negative numbers. So option 3 B is the correct answer. So we don't need to completely calculate like this. Just taking the prime factorization, again grouping the factorization and take one number from the each group and again solve, simplifying this. Okay, instead of that we can solve it in this by applying the short trick. Then the next question is the cube root of 8 cubed is. The question given like this: the cube root of 8 to the power of 3 is, options they are given, a is equal to, a 2, b is 4, c is the 8 and option d is the 16. So now what we are trying to ask is the cube root of 8 to the power of 3 is the value of 8 to the power of 3, how the cube root of 8 to the power of 3, how much they are asking. Okay, so for this, if you know the formula, just the cube root and cube are inverse operations. If you know this idea, okay, concept, then we can, by seeing the options itself we can say that. Okay, so the cube root and cube are the inverse operations actually. So that means if 3 to the power of, so the a to the power of 3 is equal to a. Okay, so isn't it? So this we can write it as a to the power of 1 by 3, and where they will cancel, the value become the same only, whatever the value. So in this case what we can do, 8 to the power of 3, so that means it becomes a only 8. Option C is the correct option. Okay, so this is a just by remembering the formula we can try to identify the cube root of 8 cube. Similarly, if you solve, how it will, what is the solution, answer will come like, so the cube root of 8 to the power of 3. So 8 to the power of 3 we can write it as 8 into 8 into 8, and then we will get the 512 again. So therefore the cube root of 512 again becomes a 8. Okay, so if you just go regular way of how to identify the factors, okay, the cube root through the factorization or like this, we will get the same answer. So instead of that, if you remember this formula, we can directly, by seeing the options itself, we can identify the cube root of the given numbers. So remember always, if a number is in the form of n to the power of 3, then the cube root is always n. So now if you see that the given number, okay, so n is equal to 8, it is in the form of n to the power of cube, so therefore the cube root always becomes a n. Okay, this is the one thing. If number is raised to the power of 3, then the cube root always gives back to the number. Okay, so therefore, and based on this concept, we are confirming that the given for the given question answer is the 8. Now, next question: which statement is correct? If the cube of a number has 4, 5, or 6 digits, then its cube root has, option A, 1 digit, option 2, 2 digits, option 3, 3 digits, option D, 4 digits. Okay, so what they're trying to ask in this question, let's try to look at. If the cube of a number has 4 or 5 or 6 digits, then its cube root has how many digits? Okay, so now let us see that. Okay, what is the concept which is one mark? What concept the question is asked? If a number has n digits, then the cube root has approximately n by 3 digits. Suppose let us take, okay, so they have given here, if a number has n digits and its cube root approximately it will be having the n by 3 digits. So now if let us take the 6 digits, okay, they have given 4, 5, 6 digits. If you take the n is equal to 6 digits, okay, the approximately it may be having n by 3, so that means 6 by 3, we get the 2, approximately it may be having the 2 digits. Okay, so one we can say that. Similarly for the 5, okay, so 5 digits there again, n is equal to 5 and n by 3 is equal to 3 ones are approximately 1.5, something we will get it. Okay, so we can say that, okay, approximately 2 digits again we'll get. Similarly for the 4, okay, so 3 ones are 3 and again 1 point something we'll get it. Okay, so based on that we can approximately we may get it the 2 digits. So by just remembering this concept formula, we can also identify from the answer from the given option, so that we can say that it is a 2 digits. But let us try to see that in a regular way, how we can, based on the concept, how we can identify this answer for this question. Okay, so now let the cube of a number has 4, 5 or 6 digits. Okay, so how digits in the cube? Okay, so in the 4 digits, that means like let us take the smallest, what is the smallest 4 digits number is a 1000. Okay, so that we can represent as a 10 to the power of 3. And what is the smallest number of smallest number with that digits, 5 digits? It is 10,000. Okay, so that can be represented as a 10 to the power of 4. Similarly, smallest number of the 6 digits, so that is 1 lakh, can be represented as a 10 to the power of 5. Okay, so now for each thing, how many digits it has? A 2 digits only. Okay, 2 digits. So therefore, by confirming this also, we can say that for the statement is the correct, which is having the 2 digits only. Okay, in all the cases the cube root has the 2 digits, so the correct statement is the option B. If the cube of a number has n digits, then its a cube root has approximately n by 3 digits. We also verified by saying, applying this formula also. So always divide the number by digits in the cube by 3, which gives the approximately number of digits in the cube root. Now, next question, find cube root of 343 into 1331. The options are given like this. Option A is equal to 47, option B is equal to 49, option C is equal to 67, option D is equal to 77. Now how we can identify this? Okay, the given cubes they have they have given cube root of 343 and another cube root is given 1331. Okay, for that we need to identify what is the value of that. Okay, so now what we have to do first here, recognize the perfect cubes of from the given numbers here. So what are the given numbers here? 343 and 1331. Okay, what are the given numbers? 343 and 1331. Okay, now what is the cube of the value of the 343? What is the cube of the value of the 343? So 343 we can be write as the 7 to the power of 3, or 7 cube we can write it. So if you do that 7 into 7 into 7, then it becomes a 343. So therefore we can say that 7 to the 7 cube is the perfect cube of the 343. Similarly for the 1331, if you do with the 11 into 11 into 11 cube, the value of the 11 cube is the 1331. So that means we can say that it is 11 cubed is equal to 1331. Okay, so this also can be identified by doing the prime factorization method, isn't it? Or we can also see that by just looking at the unit digit method, unit digit, and we can also in the same similarly 1331 also look at the unit digit and then try to identify which is the nearest or approximate or perfect cube root of the given numbers. Okay, now the formula, the property which is given, okay, if cube root of a to the power of 3 into b to the power of 3, then the value is a into b only. Okay, now from the given, if you see from the given question here, okay, what is the a value here? A is equal to 343, b is equal to 1331. Okay, so which is, it is in the form of this property. So cube root of a to the power of cube and b to the power of cube is equal to the values a into b here. Okay, now let us apply the given values into this property. Now cube root of 343 and 1331 equal to, this can be written as 7 to the power of, so that means 343 we are writing as again 7 to the power of 3, and this one we are writing as 11 to the power of 3. Okay, so therefore what we can do, so we can what we can write, so 343 can be written as 7 to the power of 3 and 1331 can be written as the 11 to the power of cube. Okay, so now if you simplify this one, 7 to the power of 3 1 by 3 and okay, and 11 to the power of 3 1 by 3. Okay, if you simplify, how much you will get? This one will get cancelled. Okay, so then we will be left with only 7 into 11. So now if you multiply this 7 into 11, the answer will be the 77. So therefore we can confirm that the cube root of the value of 343 into 1331 is the 77. Which option is correct? In the option, if you see, the option D is the 77. This is the correct one. Okay, now key steps which we need to remember when you're trying to solve this question. Identify each number as a perfect cube and take the cube root of each one and multiply the cube roots. Okay, you don't need to do when you see this kind of question, directly do not do any multiplication within the cube. Okay, so first you try to recognize the perfect cubes, which are the perfect cubes of the given number, and take the cube root of each one. Okay, and then multiply the cube roots. Okay, so then we'll get the solution easily. So now when you apply into the question, we'll get the solution. So how does it work? Okay, if a is equal to x cubed and b is equal to y cubed, then we say that 3 to the power of 3 to the cube of a into b is 3 cube of x to the power of 3 into y to the power of 3, that is become x into y. This is the property which we are trying to say here. So remember this formula, this property. So when you see this kind of questions, automatically, easily, without much calculation, just identifying the perfect cubes and applying this property, we can get the solution. Now the next question is, which number has the cube root ending in 8? The options they are given like this. Option A is 216, 216. Option B is 512. Option C is 343. Option D is 729. Okay, so they are asking which number from the options so has the cube root ending in 8. So these are the numbers options. So one number which has the cube root ending in 8. Okay, now for this what we have to do, if you remember the unit digit trick, okay, so you don't need to remember all the cube roots. If you remember from the basic from 0 to 9, okay, directly without solving we can try to answer for this question. Okay, so now let us see that. Okay, 0 is always cube root ending with the 0, 1 is always end with the 1. Okay, and 4 is always cube of the 4 is always cube root end with the 4. Okay, then 5 cube of the 5 is always end with the 5, and the cube of 6 always end with the cube 6. Okay, and the cube of 9 always end with the 9. Okay, so there are 1 2 3 4 5 6 numbers which as end with the same number only. This is the pattern which we need to remember. Okay, then if you see the cube of the 2, okay, the cube root it ends with the 8, and similarly if you see the cube of 8, it ends with the 2 in the reverse case. So that means 2 always cube root ends with the 8, and the 8 of the number of the cube always it ends with the 2. So this is the one thing which we can remember. Okay, then similarly 3 always ends with the the number of the cube of the 3 always ends with the cube root 7. Similarly the cube of 7 always ends with the 3. Okay, so this you can remember. If you remember these things, okay, so many of the questions comes from the concept of the cube and cube root. Usually be based on these concepts, unit digit trick only we can solve many problems. For this also, now if you see which number has the cube root ending in 8, so now 8 must be end with the 2 only. So in option if you check what is the unit digit 2, where it have the 6 or 2 or 3 4, option B has the 512. So we can say that option B is the 512 is the correct answer for the question. Okay, but let us try to see that, okay, whether it is correct or not. Cube root ending in 8 means the unit digit of the cube must be end with 2. Okay, so therefore if you see the first option A, 216, okay, so that can be written as the 6 to the power of 3, so which comes 2 to the power of 6. Again it is ending with the 6, so it's not, this is the wrong answer. Okay, now 512. Okay, so 512 if you see 8 to the power of 3. Okay, so 8 to the power of 3, again it is so that means in the unit digit if you see it is ending with the 2. So 8 cubed is ending with the 8, that means 8 is ending with the cube root of the 2, so therefore we can say this is the correct answer. Let us see other options also. 343, okay, so 343, the cube root of the 7 to the power of 3, okay, 7 to the power of 3, again it is ending with the unit digit is the 3, so therefore we want unit digit which ends with the 8, okay, so therefore this is the correct answer, so wrong answer. And then 7 to the power of 29, 9 to the power of 3, okay, so this is also ends with the 9, so therefore these other three options are the wrong and only option B is the correct. So just remember this cube ending and root ending of this 0 to 9 and easily you can solve these problems. Next, the next question is the smallest number by which 68,600 must be multiplied to obtain a perfect cube, okay. So in order to get the perfect cube for that number, we need to multiply with the smallest number of the given options, okay, so then we get a perfect cube, okay. They given the number, the n number something 68,600, and they're asking you to, for that number we must be multiplied to obtain a perfect cube, so one number which is the smallest number. So just by seeing the options we cannot say that the 2 is the smallest, so therefore so, okay. So now let us try to see that which is the smallest number. If you multiply with the number we get a perfect cube, okay. So now what we have to do for this kind of questions, whenever they ask you whether it is a square and square root, whether it is a cube and cube root, okay. So what we have to do whenever they ask the smallest, we try to first do the prime factorization of the, identify the prime factorization of the given number, okay. Now what is the given number here? 68,600, okay. So now how this can be written as 686 into 100, that means we are trying to simplify the larger number into simplifying form, okay. Now try to identify the factors of the 686. If you identify the factors of the 686 as in the regular method, so we will get for this, okay, we will get something like for all the 2 into 7 into 7 into 7, okay. So that is the 686 of the factors. For similarly the factors we get 2 into 2 into 5 into 5, okay. So now alright, so now how many times 2's are there here? 2 to the power of 3, 7's are the same, 3 times 7 to the power of 3, and 5 are the 2 times 5 to the power of 2. So now in order to get a perfect cube, remember the concept here, okay. To make a number perfect cube, the prime factorizes the number, make the power of each prime multiple of the 3. Even in the similar in the square root also, when you discuss in the square and square root concept also, to make it a perfect square we also multiply with the given number with the number, okay. So similarly in this case also make the power of each prime as a multiple of the 3, okay. So then multiply by the product of prime raised to the required powers. Now in this case what we have, we got it 2 to the power of 3, it is okay, it is a power 2 to the power of 3, the power is 3, so it is satisfied condition. And then if you see the 7 to the power of 3 here, the power is 3, it is satisfied, okay, in the condition, with the condition. Now then 5 to the power of 2, if you see that it is not a prime of a multiple of the 3, so therefore what we have to do, the perfect cube power of all the prime must be multiples of the 3. So now if you see the 5, it is not a perfect, it is not a multiple of the 3, so therefore what we have to, we need to additional 5 is required. So for that means we need a 5 to the power of 1 more is required. So in order to get that one, so what we have to do, you have to make it a perfect cube. So with the given number in whatever the, so this 68600, so this you multiply with the again 5 in order to get the perfect cube. So with which number we are trying to, the smallest number we are trying to multiply in order to get the perfect cube, so that is the 5. So which is the option, that is option D is the correct. So 5 it is there in the option D, so therefore we say that option 5 D is the correct answer in order to get the perfect cube of the given numbers, okay. So the concept which is given here, a number is a perfect cube if the prime factors has all powers in multiples of the 3. So if the number given number, if you have the powers, all the prime factors of the powers in the multiples of 3, then we say that it is a perfect cube. So now when you multiply this one, what will become? This will become 2 to the power of 3 and 7 to the power of 3 and 5 to the power of 3, okay. So when the condition is satisfied, all the prime numbers are in the multiples of the, therefore we say that it is a perfect cube, okay. Now next question, find cube root of 350 square minus 350 0 plus power of 0 plus 16 and 350 power of 0 plus 2. The options are given like this. A is equal to A is the 4, B is the 6, option C is the 7, option D is the 8. Okay, so now there are two concepts which are involved in order to solve this problem. Okay, so one is that loss of exponents, which we need to recall here. So because the number, so the cubes they are given in the form of the question has given in the form of exponents. Okay, so where like 350 power of square and 350 power of 0. Okay, so now if you recall that a to the power of 0 is equal to 1, so that means here the value 350, if you consider a, that is a is equal to 350. So based on the law of exponents, we can say that 350 is 0 is equal to the value of 350 of 0 is 1. Okay, then the another concept is a to the power of m by a to the power of n, a to the power of m minus 1. So these concept formulas which we need to apply in order to solve this problem. Okay, now simplify using the laws of exponent first, then then find the cube root. Okay, now let us try to apply the laws of exponents here. Since a to the power of 0 is equal to 1, so therefore we can write 350 to the power of 0 is as a 1. Okay, so then 350 square we can add. So if you multiply 350 into 350, the value of 350 square becomes this much. Okay, so 12 lakhs 2500. Okay, then now we got it the value of the 350 and we got it the value of the 350 square. Only these two values which we need to identify. So which are the, again we have the 16 2 is the whole numbers. Okay, now we got it these two numbers. Now what we have to substitute these values into the given expression. Okay, now cube root of 350 square minus 350 power of 0 plus 16 by 350 power of 0 plus 2 is equal to cube root of, what is the value of 350 square? We got it this much, so that value. And what is the value of 350 cube? Minus 1 and plus 16 by, what is the value of 350 power of 0? 1. We are substituting that one and plus 2. Okay, so when you simplify this one, we'll get it. So 12250 plus 16, it becomes a 16, and then minus 1 becomes a 515. 12 lakhs 2515 by 1 plus 2 is equal to 3. Okay, so now again if you simplify this one, we'll get the value of 40838.33. Okay, so where we do the division, then if you do this one, we'll get the answer of 40838.33. Okay, so now we need to identify for the perfect cube. Okay, so how we can do? So now 8 cubed is equal to 512. Okay, so where 8 cube we can write, the value of 8 cube we can write in the form of this one. So we can say that the value of 8 cubed is, the value of 512 is the 8. Okay, so now what will become, so now based on this we can say that so cube root of 350 square minus 350 power of 0 plus 16 by cube root of 350 plus 2, the value of A is the 8. Okay, so which is in each option it is there. Option D is the correct answer. Okay, so others are the wrong answers. So now, so for this, the basic common perfect cube, still we can remember like 1 cubed is the 1, 2 cubed, so we can till 20. So these are the important even square and cubes also till 20 we can remember that. Therefore whenever give the problems or based on the cube and cube roots and square roots, okay, it will be easy to solve the problems when you remember the perfect cubes and perfect squares of the numbers till the 20. So okay, so 2 cubed is equal to 8, 3 cubed is equal to 27, 4 cubed is equal to 64, and 5 cubed is equal to 125, and 6 cubed is equal to 216, 7 3 is equal, cubed is equal to 343, 8 cubed is equal to 512. So till 20 if you try to remember, it will be easy to solve. Then next question is find cube root of minus 91,125 and cube root of 512. So what is the value of this one? When you simplify this, what is the value we will get? So let us see now. Okay, remember the cube values. Okay, so now 25. Okay, when you say the 25, okay, so check with the in the unit digit which ends with the 25, so therefore check with the 5. Okay, so when you check with the, like 15, obviously 5 will not be possible. 5, 15, 25, 35, 45. Okay, at the 45 it will become the value, at the 45 cubed the value will become a 91,125. okay, similarly 512. okay, 512. okay, so now if you see the 5 is, if you remember the cube and cube root of ending. okay, the digit 1, last digit it's when ends with the 2, so which is the number which ends with the 2, so only there is option 8 ends with the cube of the 8, cube root ends with the 2. okay, so therefore 512 8 can be written as a 8 to the power of 8 3. okay, now what we got it the value of this one and this one. Now we need to try to simplify that one. okay, when you simplify, so how much will get it? So the value of the cube root of value of 91,125 is the minus 45, and the value of cube root of 500 is the 8. okay, so now if you simplify, minus 45 minus 8, okay, we'll get the minus 53. so which is the option 3 is the option D is the correct answer for this one. So just identify the value of the cube roots for the given numbers and then simplify, easily will get the answer. okay, then yeah, so where we also given the here negative. okay, so whenever you see the negative, cube root of negative number is always negative, as we discussed. okay, cube root of negative always will be the negative only. The next question is, if q is the square of a natural number p, then find the p. okay, so very easy question. okay, so options are given, q, b is the q square, and option c is the root q, and option d is the q plus 1. okay, so what is the option correct answer? Let us see that. okay, if a number is the square of another number, then taking the square root gives back the original number. okay, so what concept we need to remember here? If a number is the square of another number, if any number n is equal to something 2, 3, 4, okay, if it is the square of another number, then the taking the square root gives back to the original number whatever it is having. So that means if q is equal to p square, and then p becomes a root q. okay, so if p is equal to q square, then we can say that p is a root q. okay, isn't it? So now so for this, okay, if q is the square of natural number p, and then q, that becomes a p square, taking the square root on both the sides, okay, where we get cancel, and root q is equal becomes a p. okay, so therefore we can say that p is equal to root q. Next, find 0.09 into cube root of 0.0064. okay, so the value they are given, we need to identify which is the correct, so that means we need to try to simplify this question and identify which is the correct answer value of for that. okay, option A they are given 0.036, and option B 0.0036, and option C is 0.0036, and option D is 0.36. so when you simplify this one, which is the correct one, we have to see. So how we can simplify this? The concept which is involved here, the cube root of a decimal numbers. So with the given value, if you see that this is in the form of the decimal numbers. okay, so now 3, this is in the form of 3 cube root of a is equal to b, where b cubed is equal to a. so in this concept which is the there. So now if you see that, okay, 0.00064, this take it can be written as 0.0, can be written as 0.04 whole to the power of 3. How we can write? okay, if you see even unit digits, the unit digits, let us see that, okay, which number which is trying to, and cube of the number, cube root is ending with the same number. So therefore based on this we can try to look at that. So 0.04 whole to the power of 3. so now the value of cube root of 0.0064 is becomes a 0.04. so we have the 0.09, so only we need to identify this value. Now we identified this is the value 0.04. okay, so that is what, because when you identify that value, then step 2 what we have to just multiply the number. okay, so 0.09 into 0.04 substitute and apply, then we will get the 0.0036. so therefore the answer becomes 0.0036. now if you see the which option B is having the 0.0036. okay, so just remember the formula whenever they ask in the form of decimal number. Okay, so remember this formula and then we'll get the apply into this, then we'll get the solution. Okay, so where they already given one decimal number and the other number they'll give in the form of the cube root, and we have to convert that decimal into cube normal number, and then we try to simplify the question. Okay, so that is what we have to remember. Convert the decimal inside the cube root into a perfect cube and find the cube roots easily, and then multiply with the given decimals. So these are the basic things which we can remember. 0.02 that means 0.008. Okay, so if you remember till 0.07, 0.09, 0.09, so this short things will help you to solve whenever the questions given from the concept of the decimal, so which will help you to save the time. So now in this session, we almost come the end of the session. In this session we have discussed, let us try to recall what and all we have discussed. We discussed the concept of the cube, and we discussed the concept of the cube root and identifying the cube value and cube root through the prime factorization method. And also we have discussed the cube roots of the fractions, and we also discussed the cube root of the decimals. When they give in the form of the fractions, how we need to identify the cube root, and when they give in the form of the decimals, and how we can identify the cube root. And also we have discussed some of the unit digit tricks. Okay, and so these all the concepts which are discussed by solving the previous year questions from the 2011 to 2026. Thank you.